Hello everyone, I'm Adam. For this problem, what we're going to be doing is taking a look at our four vectors here. For part A, the vector with components -6, -4, 10. B, vector with components 2, 4/3, and -10/3. C, vector with components 6, 4, and 10. And D, vector with components 1, -4, and 2, and seeing which of these vectors, if any, are parallel to our vector Z with components 3, 2, and -5. So to get started, let's remember, what does it mean for two vectors to be parallel? Well, in general, for two non-zero vectors, say u and v are parallel if they can be written as scalar multiples of each other. So they're parallel if we have that, say, u is equal to some scalar c times v, where we're saying c is a scalar. Okay? So before we get started with this, and just go into kind of doing the math, is let's try to understand what this means. What does it mean for two vectors to be parallel if they're scalar multiples of each other? So let's take a look at this. So let's suppose we have some vector, say v, and then some vector u, which is parallel to v. Now, keep in mind, what does scalar multiplication with a vector do? All it does is changes the length and possibly the direction, whether it's positive or negative. So this u can be, if you see, it's supposed to be drawn parallel as best we can, but it's extended. So it's just multiplied by some scalar of the vector v. Or here, of course, we'll suppose that c is positive. Now, of course, if c is, or the multiplication with the scalar is negative, we'd have a parallel vector just going in the opposite direction. Namely, if we had something like u equals -c times v. Okay? So that gives us a pictorial idea of what this is saying. Now, let's get to the math part. So, how do we show two vectors are parallel? Well, let's start with our vector A. Okay. So our vector A, we have components -6, -4, and +10. We want to see whether this is equal to some scalar multiple, which I'll fill in just a moment, of the vector Z, with components 3, 2, and -5. So we want to fill in, can we find some scalar multiple on the outside? Now there's two ways to do this. The easiest way is if you're just really good at seeing number patterns, we can look at this vector and see, is there any number that I can multiply each of these components to get the corresponding components over here? Well, if we take a look at it, we have 3, 2, and -5, -6, -4, and +10. So it looks like numerically each value is being doubled, but also the sign is changing. So it looks like the constant c would just be -2. So we multiply through by -2, we get -6, -4, and +10. So these two vectors are parallel. Okay, let's take a look at the vector B. So our vector B, with components 2, 4/3, and -10/3, right, we want to see if this is equal to, again, some scalar multiple of our vector Z with components 3, 2, and -5. So you could play the same number game, but for my sake, it's not so obvious what scalar we should multiply through to get 3 to equal to 2, 2 and 4/3, and -5 and -10/3, if in fact there is one. So we're going to take a different approach. we'll just put a general constant c, or scalar c, on the outside, and we'll try and solve for this. So again, we want to see whether this scalar c times 3 will equal 2. So we can set up an equation, 2 equal to c times 3, and see what scalar will give us that. See what scalar times 2 will give us 4/3. So 4/3 equal to c times 2. And what scalar will give us negative 10/3? Or negative 10/3 equal to c times negative 5. Now, solving each of these equations, it would be the same value of c for all of them. Then that means it's this single scalar on the outside, and they're parallel. If they're different, or any of them are different, then they're not parallel. So let's begin. We look at 2 equal to c times 3, divide both sides by 3. We get 2/3 is equal to c. Look at our next one, 4/3 equal to c times 2. If we divide both sides by 2, we're dividing our numerator by 2. 4 divided by 2 is going to give us 2 in the top, which again is 2/3 equals to c. So far, so good. And lastly, dividing both sides of this equation by negative 5, we divide the numerator by negative 5, which would give us a positive 2 divided by 3, and that's equal to c. So we get the same scalar c for all. So these are scalar multiples of each other, so they are also parallel. Okay, and let's take a look at our last two, starting with c. So we have our vector c with components 6, 4, and 10. Now, I'm going to get us started off doing the same way we did in part B. We want to see if this is equal to some scalar times our vector z of 3, 2, and negative 5. So it's not so clear to me, so I'm going to do this equation solving method for each component. So we'll take a look at the equation 6 equal to c times our component 3, 4 equal to c times the component 2, and 10 equal to c times the component negative 5. Okay. So once again, what we want to see, if they're parallel, is that we have the same value of c for each equation. Well, starting with the first, we divide both sides by 3. We get 2 is equal to c. Second equation, divide both sides by 2. Well, we again get 2 equals to c. So far, so good. And if we divide both sides by negative 5, well, we end up with a negative 2 equals to c for the last one. So we don't get the same scalar c for all equations. So the entire vector z can't be written as a complete scalar multiple of one scalar times our vector for c. So these two vectors are not parallel. All right. And lastly, let's take a look for the vector d. So our vector d, we have components 1, negative 4, and 2. And we want to see if that's some scalar multiple, some c times our vector z, components 3, 2, and negative 5. And we'll get started doing the same equation solving technique. So we want to see if the component 1 is equal to c times 3, negative 4 is equal to c times 2, and is 2 equal to c times negative 5. Okay, so getting started off, 1 equal to c times 3, we divide both sides by 3, we see we get 1/3 is equal to c. Looking at our second one, divide both sides by 2, well, we get negative 2 is equal to c. So right away we could stop. We see we're not getting the same value of c, but we'll go ahead and just complete the last one. If we divide both sides by negative 5, we get a negative 2/5 is equal to C. So like in our problem part C, we don't get the same value of C, so we can't say that the vector for D is a scalar multiple of the vector Z. So these are also not parallel. So now what we're asked to do is to confirm the results of what we've shown, that vectors A and B are parallel to Z, and C and D are not parallel to Z. We can do this with a graphing utility that has the capabilities of graphing in 3D. We're not going to show this work here, but if you can graph this in a 3D graphing utility, we'll graph the vectors A and B and Z, and you'll see that they show up to be parallel, and graph the vectors C, D, and Z, and see that they're not parallel. Thank you very much.